For lecture 2 on sleep and waking, we're going to kind of go into that idea of type reductionism again. The idea of, okay, so we have sleep behavior going on here, falling asleep, staying asleep, so on and so forth. Does that map exactly to neurotransmitters in the brain, structures in the brain that we can kind of fix and kind of fix sleeping disorders? Most people believe that when you start talking about going to sleep, that a lot of people believe that serotonin, 5-hydroxytryptamine, is kind of the key neurotransmitter that leads to falling asleep. We kind of have that old idea that if you drink a glass of milk before bed, milk has tryptophan in it, that'll be converted into 5-hydroxytryptamine, which is the right name for serotonin. And if you have high serotonin levels, you'll be able to fall asleep. The research on that, as your book chapter kind of goes into, is kind of mixed on that. There is some evidence that serotonin is kind of important, but it's not kind of a one-to-one type reductionistic idea. It doesn't appear that serotonin is really perfectly correlated with falling asleep per se. A substance that seems much more likely to be a target of falling asleep is the one your discussion board was on with that pharmaceutical product by Takeda. The product is a melatonin product. It seems when they've done research on melatonin, and I think I have an appendix to kind of support this, one of the writings on this, they actually did a meta-analysis that looked across all the different studies, and they actually found that melatonin seems to be secreted in a large amount by the pineal gland when we're falling into our deepest stages of sleep. So melatonin seems to be much more reliable a predictor of sleep, and as you can tell by what you're reading and even the description in the appendix that I have, they're actually doing clinical trials in that. I looked on that pharmaceutical website, and they're doing trials in Japan to help people with insomnia now, and probably at some point they'll try to get the product marketed in the United States, obviously, as well, because they've got phase 3 studies going on that are actually showing melatonin can actually induce some sleep per se. Once again, the serotonin, and I didn't say the structure, there's a lot of serotonin in the raphe nucleus that's in the hindbrain. The melatonin is in the pineal gland, so the idea of targeting that to help people with insomnia could be a big blockbuster, obviously, for the pharmaceuticals per se. Another structure that seems to be very, very important is a structure, there's some details with the structure, but it's generally in the pons, the structure called the pons. The pons has a lot of acetylcholine in it, and it seems very interesting what happens with acetylcholine. And I'll have to include a thing or two in your appendices with this. Acetylcholine seems to be very predictive of when people go into REM sleep. It seems that if you put acetylcholine into the brain, and right before people go into REM sleep, you see these waves start out. They're actually called, and I think your book may have a thought or two about it, they're called PGO waves. They're EEG type signs, and what they basically are is, let's see if your book does have something. If not, I'll send you an email with it. The idea is, it doesn't look like it has anything. These PGO waves, you start seeing right before somebody is going into REM sleep, you start seeing these waves start first in the pons, then in the geniculate, which is the thalamus, and then in the occipital lobe. You see these big electrophysiological spikes in the EEG, first in the pons, geniculate, in the occipital lobe. The thought about these waves is maybe they are predictive of going into REM sleep, because if your occipital lobe is being activated, that's where your visual centers are. And certainly when people go into dreaming, there's a lot of visualization going on during dreaming. So it seems that acetylcholine is very predictive of going into REM sleep. So kind of in the type reductionistic idea, acetylcholine might be very important for sleep and dreaming here. Notice that we're talking about acetylcholine here for REM sleep. In the previous unit, we talked about acetylcholine receptors at the neuromuscular junction with movement per se. So these are two very different functions of acetylcholine and maybe different receptor subtypes for it. So acetylcholine seems to be part of that. Finally, when we wake up, there is a structure called the locus coeruleus. the locus coeruleus, and there's a lot of norepinephrine in the locus coeruleus. And so it seems when people are waking up, you seem to have a lot of norepinephrine activity in the locus coeruleus. And the idea behind that is maybe norepinephrine in the locus coeruleus is kind of a type reductionistic idea with staying awake, per se. And so serotonin seems to be the weakest of the group. Melatonin really seems to map to falling into a deep stage of sleep. Acetylcholine seems to be mapped to the idea of getting into REM sleep, and norepinephrine in the locus coeruleus seems to be mapped to waking up and being alert and awake, per se. So that's kind of the neuroanatomy, neurochemistry of sleep, and obviously there could be a lot of psychopharmacology there as well.